Hi, my name is Ralph Rabat. I'm the head of predictive analytics at Uber. And I am here to tell you a little bit about the problems that we solve at Uber. But at the same time, there's a lot of things that problems that we solve that corporate communications, would not let me talk about. So forgive me if I, tell you about a few of the things that are obvious, and for the things that are more planned for the future, I will not be able to talk about them too much. So with that, I'll start. So I'll be talking about Uber in general, the products that we have, the ecosystem, and what makes it challenging, the role of data science in making sure that the company, the marketplace are running smoothly. I'll give an example of my team, which is Crystal Ball, and the technical challenges that we have and the mission ahead. All right, so a little bit about myself. I started at Uber not too long ago, about 3 months ago. I came from a background working with search engines, very large scale, content systems, runtime systems, classifiers across the board, data warehouses, knowledge graphs that I built over the years, and business analytics, data warehouses. So this is, for me, the reason why I joined Uber was more than just the work. I saw a mission there. I saw that it was making the transportation for everyone becoming more efficient. I love to save time myself. There's so many hours in a day. It definitely, made my life better as a rider. And then on the other side of the equations, there's all the driver partners that are now able to make an income. They are able to provide to their families. We get essentially people that are coming from developing countries, single mothers that are saying now, thank you to Uber, now I can feed my family. Otherwise, I wouldn't have had the job. So in addition to making things efficient, there was the mission part that was basically making things better for everyone. And then a big part of also joining was the culture. Culture at Uber is hard to tell from the outside. You hear about news about how Uber is going against legal things and laws, and at the same time people are delighted, etc. So how is it inside? I'll give you a few things that we really look at in terms of like when we are looking for prospective folks to come in. So that gives you an idea of like how it is inside. So one of the things that we emphasize on a lot is how super pumped are you? We use that a lot actually inside the company. How excited you are about doing what you're doing. How much do you have hustle in you to make things work, to make things happen? We don't have a culture of excuses. There are no excuses. If you have a blocker, you're welcome to go and solve it. You build it, you contribute to the team that is blocking you, they review your code, done. You ship it, there are no blockers. So healthy conversations, healthy debates are happening all the time. So I want to make sure that you're able to have that almost every day, and essentially being an owner, not a renter. So whatever you work on, you consider it yours, and not like renting a vehicle where you will never wash it, you will never take care of it. It's really about owning your own code, owning your own product, owning and making sure that the quality of that product is at the highest level. There are many more cultural values that we look at, but these are a few that I wanted to share today. All right. So Uber in general is Uber's mission is about transportation as reliable as running water everywhere and for everyone. In addition to that, these days it's everything, not just everyone. It's about making transportation just of anything that you can think of go from point A to point B in a very reliable fashion. The services are many that you will probably know about: Uber, UberX, Pool, Black, Uber Rush, getting packages, Uber Eats, getting you food, even things like Uber Kittens, like you can get get kittens to you delivered to your door. Uh, so optimization of routes to be able to do that transportation in a very efficient way. You want to make sure that everything is optimized. Optimizing routes, optimizing presence of driver partners, optimization of riders, and figuring out where to where to have everything at every single point in time across the world, in every city in the world. You can imagine that we have our own, mapping technology. We have maps, mapping of things on maps, and being able to calculate fastest routes continuously, so that we optimize essentially every transportation from any point to another point. And the having an efficient ecosystem is the only thing that gets us to win. So we look at it as a marketplace. There's supply, there's demand, and having continuously healthy balance between supply and demand is crucial. Having too much supply in terms of like driver partners is not efficient for your ecosystem. Having too many riders is not efficient. You don't want to have too many riders with no cars around. The last thing that you want to see is, you open your Uber app and and it says, no cars around, sorry. It's very disappointing, especially when you're planning to rush to a meeting. So maintaining these things in balance and growing both of these continuously is a very intricate and very difficult and very challenging problem that we continuously solve across the cities in the world. Okay, so what makes the ecosystem a rather interesting one? It's real time. It's happening as we speak everywhere around the world. Having essentially a person at any point in time being able to go from point A to point B is something that we need to guarantee. So at every point in time, in real time, making sure that it happens. It's very large scale, as you can imagine. I can't remember how many seconds. I think it's like 2 or 3 seconds. We have a signal back from every phone out there that is running, from riders, from drivers, and all these transactions are happening continuously. After you pay, after you during your trip, in terms of like computation of what is happening, who's going from point A to point B. Are they essentially on the planned route? Is there fraud involved, etc. To be able to make sure that we have a very well-oiled system at scale. So I come from a world of search engines and stuff. So you need to be able to know the current state of everything that's out there, all the documents that are on the web, and what they relate to and what they're connected to. It's necessary also to do that in this case, but it's also crucial to predict the future. If we can't predict, how much demand there's going to be at every single point in time, at every single geo, at every hex in the world, then you might just not like the system. So the ETA will be too much, or you won't have cars around, or all sorts of problems can happen. So predicting what's going to happen in the very near future, weekly, hourly, weekly, monthly, and yearly, is very essential, because you're making sure that your marketplace is healthy. It's not by chance that it's happening, that you're getting a car every time you open the app. It's really not by chance. Um, so this is where predictive analytics come in very handily. And then to be able to do a good job at predicting the future, you need to be able to analyze all things in the past and all things in the current time. So if you have planned something, if you have planned that you are going to have, for example, rush hour at 5 p.m. during a weekday, well, yes, that happens. But then what about if suddenly there's a road closure somewhere? So you need to be adaptive to all these things that are happening in real time, and rebalance your whole marketplace. You rebalance your drivers, you rebalance your riders, to see where they are, where the demand is going to be, where the supply is going to be, so that everyone is able to go to a separate route. Everyone is able to find their next step, and to be able to again have an efficient marketplace. So personalization is something that is usually a nice to have. In this case, it's a must. You can't assume that everyone is the same, that everyone is, for example, an existing driver that has been driving for a month. You can't assume that everyone has the same car. You can't assume that people are sensitive to the same incentives. You can't assume that people are willing to go anywhere for whatever trip is presented to them. So going from here to Sacramento, I may be able to take you there, but I will likely not, because I want to go home tonight. So personalization is a must. It's not a nice to have. So the combination of these six areas makes the problem at hand very interesting, very challenging, and being able to leverage all this data that we know and all the data that we may not know in the near future that is coming is essential to make sure that the Uber is running well. So where does data science come in here? Give you an idea of the scientist's background. So there are two main kinds of folks. One is ex-Wall Street, hedge fund, investment banks, quant guys, quant folks, and scientists. And traditional Silicon Valley data scientists. Both of them are working on various problems at hand within the company. When you think of marketplace, when you think of prediction, when you think of being able to manage budgets, operations, etc. So this is where the Wall Street folks come in and find their turf. When you're doing all things classification, all things mapping, optimization, etc. So you get more of the traditional Silicon Valley folks. So day to day, they essentially go from idea all the way to experimentation. So we have an experimentation platform so that they can try any idea they want and then deploy it. So the systems are very well set up in a way so that a scientist, even though they may or may not be experts in Java or some language that we use in production, they are able to deploy things on their own without needing any help. And then measurement. So whatever is being deployed has effects on riders, has effects on drivers, on NPS scores, so in terms of like happiness of everyone, and efficiency of the system, and market share, of course. So we measure essentially every single bit whenever we deploy a new idea, whenever we deploy, um, um, an idea, be it an increment of an existing product or a completely new product. So this is where data science comes in and is very empowered to do all these steps from idea all the way to getting results on their own, no help needed from engineering. Um, One interesting area is fraud detection. So I'll give you a couple of examples of behavior sometimes that may or may not be fraudulent, and developing these models so that you identify quickly and very quickly what is or is not a fraudulent transaction or fraudulent behavior that you observe in terms of like the route. Um, is essentially something that you trust, or you have to stop right there and then. So if you let someone go, from here to Boston, and you don't catch that person somewhere in the middle, you're incurring a lot more money from by the time they get there. So being able to detect these things in real time is essential. Trip optimization, of course, it goes without saying. It's very core. So a lot of riders come in and they, for example, start suggesting to the driver, "Why don't you go left? Why don't you go right? I know this is better," etc. So having the best optimized, mapping and directions is crucial. We get a lot of signals from all the operations that are happening on the ground that we take back in to improve our mapping, to improve at every second of the day what is the best route. And then they work very heavily on forecasting of driver partners and riders especially in hypergrowth mode. So as you can imagine, Uber is not just increasing a little bit every month. It's increasing very, very quickly. So whatever predictive analytics you're running are you want to take into account where you're deploying them. If it's in a mature market or a hyper growth market, so you want to be able to figure out like what are the right models that you need to deploy, because in a hyper growth market is if you're applying more traditional incremental growth, you're way off, and therefore your whole system will crash. If you're and then it's very hard to get back and remedy to that. So hockey sticks are very common ground. I was in startups before. We always talked about like how can we show these hockey sticks. This is what will get you the money. We have so many hockey sticks in every city that we deploy that it's basically just becomes like the day-to-day routine. So how do you plan for that? Because it's going to happen. So that your forecast is as close as possible to reality. So it's not an incremental improvement, a small incremental improvement that you see. And then science is integrating both quantitative and qualitative data. So you have trips, you have transaction, you're going from A to B at a certain time in a certain geo. A transaction is happening, be it cash, be it credit card, and then there are things that are more qualitative. So what about if it's going to rain tomorrow? How does that affect my supply? How does that affect my demand? Is that going up? Is that going down? Is it just a little bit of rain, or is it super heavy where people are essentially going to stay home? So there's a delicate balance between these. Knowing what events are going to happen in the near future. So be it a concert, be it a ball game, be it whatever big event that is happening in everywhere in around the world is part of like integrating of the system. And then you have to guess, how many people are going to attend that event, and therefore, and what time it starts, what time do people will start going there, what time it will end, and then what if it ends a little bit earlier? So what do you do? How do you remedy to that? So it's a combination of um, uh, very transactional data with qualitative data, and then blending the two to be able to know what's going to happen, to be able to know that I need, for example, X drivers, and I will have Y riders, and they will be at that location at that time, and therefore, to make sure that they're finding each other in a quick way. So Crystal Ball is a system in general. I'll tell you the areas that it covers. So it does the forecasting, long-term forecasting, short-term forecasting, all the way to real-time forecasting. Then pricing, which I will not talk about today. And then incentives. So incentives to drivers and incentives to riders. There are what we mentioned is, for example, guarantees to to drivers as incentives, and then from the rider perspective, you can see promotions, discounts, free rides, etc. And then the platform for all these programs. So this is what Crystal Ball is. So if you look at like the layers for that, so it starts with data source management, getting essentially into the data infrastructure to secure the data that we need, and then flexible data access, real time, both real time and batch, to support multiple usage scenarios. Then you go into data pipeline, where we have a one-stop solution for data gathering and query execution, so that anyone can run whatever query they want, be them engineers, be them scientists, be them product managers. And then flexible and exact, both data aggregation and transformation. So as much as we need to have all these open source data aggregation and mechanisms and systems, we are also running them for transactions. We are also making sure that the money actually is flowing through them. So eventual consistency is not enough. So you need to make sure that you're exact at every single point in time, and so that you're running for example, your dashboards analysis of what is happening at every point in time in very exact way. And then on top of that, there's the analytics engine. So streaming data from the data pipeline directly to the engine for execution. Then a generic interface for flexible execution scheduling, where folks who don't necessarily want to deal with anything low level, anything in terms of code, they can also run things through essentially a user interface. Then complex data modeling, as well as algorithm libraries that are part of the analytics engine. Then all this data goes into two main places. One is production pipelines. So once we, for example, we calculate the incentives, once we calculate what is needed for every point in time, for every day of next week, that goes into production pipelines, and that gets deployed. So it's all the way data to actual production to what you're seeing on your phone in terms of real time. So it's not, for example, in the US, you don't see too many of those. You will see them in China, you will see them in India, you'll see them in markets where growth is not growth, where the marketplace is crazy. And then collaboration and decision-making tools and dashboards. So this is where once we deploy all these models and the predictions of what is needed for every hour, for every week, then you have the city ops coming in. For every city, there is an operations team. So although we know a few things about the world, there are things that we don't know that are very local, very hyper local, where the city team knows a little bit more of what is going to happen, be it a local holiday, be it something that they know. For example, local competition is planning to do, etc. So all these inputs are something that we don't necessarily know in our centralized engine. So this is where the collaboration tools come in, so that they have leverage in terms of what is to be deployed next week. And then so decision making. So essentially everything is driven from tools that essentially that are exposed to scientists all the way to CEO, so that these deployments happen in an efficient fashion. So the technical challenges, for example, is balancing budget and operations. So if I have a budget of, let's say, $1 million, I can very easily spend it in 1 hour. Is it the right thing to do? Probably not. My marketplace will be happy for the next hour when I spend that money, but it's not the responsible thing to do. For example, if you are giving rider promotions in a city that you just started, spending all your money in the first few days versus over a few months is a decision that you need to make, so that again you have a certain budget, you have certain operations that you're expecting, that you are forecast, that you have a goal for, and you're balancing the two together. Identifying patterns and possibly fraud transactions or behavior. So I mentioned a couple of examples. If you see a trip going from San Francisco to Boston, is this legit? I don't know. You need to look at like a little bit more data than that. So what is the behavior from that driver in the past? What is the behavior of that rider in the past? Are they using a new credit card? Is it something that has actually, have they been changing credit cards, every day in the past few days, etc. So this is where you need to be able to in addition to running your algorithms, sometimes there are things that are question marks, so you don't know. So you need a team that gets deployed to look at like these cases. Another example is 2 rides going exactly from point A to point B at exactly the same time. That raises a flag. Is that okay? Is that legit? So this is where again you look at all the details and you go into all the history, etc., to be able to identify whether it is legit or not. Seasonality, of course, our biggest peaks are, as expected, Halloween, New Year's Eve, rush hour every day, holidays. So all your models have to take that into account so that you're not off. So you're not burning money like crazy unnecessarily, for example. And then adapting models to rapidly changing conditions. I mentioned a couple of things. So for example, a game ending earlier. So how do you know that it did? And then how do you react to it very rapidly? A train, a bunch of people on a train and then it breaks down. Suddenly they need to get off the train, find ways of commuting. How can you listen to those events in real time that are unplanned? So listening to Twitter, etc., is very much needed so that you have an idea of what is happening in real time as opposed to what you had forecasted. And then it's a continuously evolving system. We're adding features all the time in terms of like Uber, so that we need to be able to continuously adapt to all the changing parameters that we have in our ecosystem. So I mentioned a few: dynamic dispatch, demand prediction, supply positioning, dynamic pricing, logistics modeling, and then everything that you do, scale it up every few months. So make sure that everything that you're running can scale up. A few X without naming a number every few months. So, so this is how we help. This is how we make. These are the challenges that we have. These are the areas that we're tackling, the problems that we're solving, and they get more interesting every day because we're adding all these business units that we are supporting. So giving looking at things from a person transaction from point A to point B is different than a burrito in the back of and in the rear seat of your car. So so being able to adapt these models to all these things that are being transported and people that are being transported is very it's very real. So that's what I had. If you need more information, you can contact me. I have my email right up there. Very simple, ralph@uber.com. So I'll take a question.
Yeah, I was going to say it's really great having Uber's BI and analytics guy here. I'm wondering if you're willing to reveal some of the technologies that you classified but did not name.
All right, I'll name a few. So, in terms of like languages that we use Java, Python, Go heavily. On the front ends, we use React. In terms of data systems, Hadoop, HDFS, Hive, Pinot, Samza. These are the ones that I can mention. There are things that we're also developing internally. So yeah.
And just a quick question, are you doing more traditional data warehousing or is it all Hadoop based?
We don't have anything traditional, sorry. It's all Hadoop based. Yeah. Yeah. So it's a combination. We are moving completely into container. There are bare metal today. And for that forecasting part, the platform that I talked about is something that we're also going to use to be able to predict how much we're going to need in terms of containers. So the same forecasting platform will be used for marketplace and hardware. It's semi-manually now. We're not completely there yet. Yeah. So the baseball game ending early is something that once you have to. One is you need to listen to, let's say, on Twitter, to know, or some events or something that gives you that information that it did end early. Then that basically moves your time from when you had essentially planned for, let's say, an hour from now to have to have the drivers ready up by a certain amount, and then you rerun your model so that you can see basically what do I need to do now and how do I remedy to that. Because if you need driver partners in the next 5 minutes, that's going to cost you a little bit more than if you need if you gave them a heads up to be there an hour later. So it's a combination of rerunning your models and then replanning and rebudgeting. Um, yeah, I can take that offline with you. I don't want to talk about that too loud. So it's a combination of engineers, systems engineers, large scale data folks, machine learning folks, and um, essentially folks that have uh, dealt with very large scale systems, very large scale data. And so it's a combination of engineers and scientists.
Ralph, thank you so much.